Welcome back to another tutorial of Real Numbers Chapter 1. So, before moving on to exercise, we will just see a theorem, that is Theorem 1.6, on which the whole exercise is based on. So, what does this theorem say? Let P be the prime number. If P divides A square, then P divides A. Let us assume any number A which is an integer, positive integer, suppose 1, 2, 3 or any number. The square of that number should be divisible by the value of P. The value of P can be anything 1, 2, 3, 4, 5 and so on. Let us see this table. If we have any integer A as 1, what is the value of A square? Here is 1. 1 into 1 is 1. Let's assume the value of P as 2. Can 2 divide 1? No, it doesn't, which is false. Can 2 divide 1 again, which is A? No, the answer is false as well. So we should write no here and move on. The value of A square is 4, which means the value of A is 2 because 2 square is 4. Can P divide 4? 2 divide 4? Yes, it does. We all know it divides. So it is yes. Can 2 divide 2? Yes, it does divide. Can 2 divide 9? No, it doesn't. 2 cannot divide 9. It is even and odd. Division is impossible. So it is no as well. Can 2 divide 3? No as well. So as we can see that when a value of P cannot divide A square, it cannot divide A as well. When the value of P can divide A square, it can also divide A. Let's go. Can it divide 16? Yes. Then it also divides 4. 4 square is 16. Can it divide 25? No. So it doesn't divide 5 as well. So this is what this theorem says. Let us see an example. So this is the procedure how we are going to solve all of the further problems. Show that root 2 is irrational. What is irrational? Which is not in the form of P by Q, right? This is irrational. We have already learned about it in our first tutorial. So we need to show that root 2 is irrational. So how are we going to do? Let us assume root 2 is rational by using proof by contradiction. So whatever the question is asking, we need to contradict that fact to prove this. So we need to do the opposite of whatever he is saying. He is saying prove irrational. So we are doing the opposite as rational. The contradicting proof we are using. If it is irrational, then there must exist two integers r and s, where s is not equal to 0, such that root 2 is equal to r by s. What is this? It is in the form of p by q. If it is rational, then it should be in the form of p by q, which is what here it is r and s, where the value of s, that is q, should not equal to 0. That is what it is saying. Value of s, that is q, should not equal to 0. This is the form of rational numbers. If r and s have common factors other than 1, then we divide r and s by their highest common factor. What does this say? Let us assume that these p by q has a common factor that is other than 1. Suppose it has 2, 3, 4 or 5, any other common factor. So we need to divide, means cancel. R and S, P and Q, cancel to get the further small common factor. So root 2 is equals to A by B. So after cancelling P by Q, whatever suppose the value of P by Q is 4 by 8. After cancelling we will get 2 by 4, right? So this is A by B. That is what it is telling. If we have a common factor, here the common factor was 2, right? We were dividing 2 and 4 and 8 by 2, 2 to the 4, 2 for the 8. So with the common factor other than 1, that is 2, we need to cancel it to get the value A by B. That is what it is saying as 2 by 4. This is just an example, okay? So where A and B are co-prime, so we need to do it in the form of if these are co-primes, but the 2 is not the co-prime, 4 is. So to get the co-primes as A and B, we need to cancel it. That is what this whole process is. So B root 2 is equals to A. We are sending this B, which is in denominator, to the numerator in the multiplication form. B root 2 is equals to a. On squaring on both sides, we get 2b square is equals to a square. If you cannot, I'll just elaborate. If we do b root 2 whole square is equals to a square, b square root 2 square is equals to a square. Cancel, we'll get 2b square is equals to a square, right? That is what we got here. Therefore 2 divides a square. If we send this 2 here, which is in the multiplication to this equals to this side, it will divide it by 2, a square by 2, right? Then b square is equals to a square by 2, which means 2 divides a square. So if 2 divides a square, it will also divides a. That is what the theorem says, right? In the previous slide, we see that theorem 1.6 says if it divides a square, it also divides a. By theorem 1.6, 2 divides a square, it also divides a. So we can write a is equals to 2c, where the value of a should be any integer, positive integer, right? As we have seen in the theorem 1.6, the value of a is any positive integer, which we are taking as c. On squaring, we get a is equals to 2c. 2c is our positive integer. We'll square it again. A square is equals to 2c square. Now, we will substitute the value of a square in the above equation, where 2b square is equals to a square, right? Instead of a square, we will write this value 2c square. 2b square is equals to 2 2s are 4, c square as it is. We'll just cancel 2 1s are 2, 2 2s are 4, it cancels. Then b square is equals to 2c square. Now, if we send this 2 again here, it also divides b square, right? B square by 2. Similarly, how we got a square by 2 in the previous slide, which means 2 divides b square, then it also divides b, right? So, but this contradicts the fact that a and b are co-prime. How we should get this? We need the values of a and b as co-primes, right? As I already said here, these should be co-prime, but we only got 2. As we only got 2, which is not a co-prime, it is a prime number. So the contradiction has arisen. Why does this contradiction has arisen? Because we assume that root 2 is rational. That is why this contradiction has arrived. So it means our assumption was wrong and root 2 is irrational, which is in general, it can be shown that root d is irrational. D is any kind of positive integer if it is not the square of any other integer. So what does this mean? Let us suppose root d is root 2. Is it a positive integer? Yes. Is the root 2 is the square of any other integer? No. Can 1 square makes 2? No. Can 2 square makes 2? No. So it is always irrational. Similarly, root 6, is it a square of any integer? No, it is not. Similar with the 8, root 15 and root 24. These are not the squares of any other positive integer. So these type of numbers are always irrational. For example, if we has root 9, is it a square of any integer? Yes, it is a square of 3. 3 square makes a 9. So it is rational. That is what this statement says. In general, root d is irrational whenever d is a positive integer which is not the square of any other integers. Prove that the following are irrational. How we have seen in the previous example, we need to prove that the following numbers are irrational. 1 by root 2. How are we going to do this? Use the contrary process. How we do it? So we need to prove irrational. We should take the opposite of it. Means it is rational. If it is rational, it is in the form of p by q, where p and q are positive integers. 1 by root 2 in the form of p by q. Let's reverse it. Root 2 by 1 is equals to q by p. Root 2 is equals to q by p, right? So what was the root 2? Always irrational, right? That is, root 2 is rational number according to our assumption. But it is contradicting the fact that says any positive integer which is not the square of any other integer is irrational. Is the fact, right? So we got root 2. It is contradicting the fact. So it is irrational. as our assumption is false of the rational. Because it is contradicting the fact, it is irrational. Question: root 3 plus root 5. Again, using the same process, considering it as a rational number. If it is rational, it is in the form of p by q. Let's do squaring on both sides. It is in the form of a plus b whole square. The formula is a square plus b square plus 2ab. Square and root cancels. 3 plus 5 plus 2 root 3 5s are 15. Right, that is what we got here. 3 plus 5 plus 2 root 15. No, 3 plus 5 is 8. If we send this 8, which is here the positive, if we send it to the right side of this is equals to, it becomes minus 8, right? Let's do the LCM, cross multiply. I'll show you how to do. Let's take whole by q square. Now we'll do cross multiply. P square into 1 is p square. 8 into q square minus 8q square. So that is what we got here. 2 root 15 is equals to p square minus 8q square by q square. Again, we will send this 2 here. As it is in the numerator, it goes to the denominator. P square minus 8q square is equals to 2q square. Root 15 has the values as p square minus 8q square by 2q square, which are positive integers, right? So it is rational number. But again, this thing is contradicting the fact that root 15 is always irrational, right? Because root 15 is not the square of any positive integer. So as it is contradicting the fact, it is irrational. So our assumption is wrong, and root 3 plus root 5 is irrational. Next question, we got root 5. Just by looking at it, we can say it is irrational, right? Because it is not the square of any. So let's prove it. So how are we going to prove? Again, we take the contrary method, take it as rational. It is in the form of p by q. If it is rational, it is in the p by q form. We need to divide. Let's take the common factor and reduce this to a by p, like we need to cancel it and see whether a by b are co-primes. Root 5 is equals to a by b, where HCF a by b is only 1, right? Because we don't have any co-primes. Now, squaring on both sides as we did in the previous example. Root 5 whole square is equals to a by b whole square. Root and 5 cancel. 5 is equals to a square by b square. If we send this b square here, 5b square is equals to a square. So, if we send this 5 back, it divides a square, right? If 5 divides a square, it also divides a. Now, a is equals to 5c. We take the value of a as any positive integer. Before we have taken as 2c, right? We are taking 5c because we got 5 here. Squaring on both sides, a square is equals to 25 c square. 5 into 5 is 25 c square. We'll substitute this value of a square here. 5b square is equals to 25 c square. On cancellation, we will get b square is equals to 5c square. B square is equals to 5c square. If we send this here, again it divides b. Again it divides b square. So 5 also divides b square and 5 divides a square. So it divides both a and b. What's the common factor here? We need a common factor that is co-prime. We have the common factor 5 which divides both, which is not a co-prime. So this contradicts the facts again. A and B are not co-prime. So our assumption is wrong and root 5 is not rational. It is irrational. Next question. Root P plus root Q is irrational where P and Q are primes. Given that P, Q are primes, hence root P and root Q are irrational because P and Q should not be prime because they only have the factor as 1. Primes have the factor as 1. But we need P by Q, which should be not prime, right? This should be composite number so that on further division it can give us co-primes. but it's already telling that we got p and q as primes. So just by this statement we can say that these are irrational because they are prime numbers. If root p and root q are irrational, then sum also is irrational. Root p plus root q is irrational. Sum of two irrational numbers results an irrational number. Moving on to next topic, that is exponentials. So what are exponentials? We know the power a power n of a number a with natural exponent n is the product of n factors, each of which is equals to a. What does it say? A power n is the product of n factors. Number of factors, how many? The value of the power. N means infinite here. A into a into a into so on. So a power n is the product of each factors, how many times? N times. Example, if we have a power 3, what is it? A into a into a. N times? 3 times. That is what this statement says. What are the rules of exponentials? We have total 7 rules of exponentials. If a power m into a power n is given, then it is a power m plus n. If it is in the multiplication, we need to add. If it is in the division form, we need to subtract the powers. If it is whole power any number, we can open this number as singles. If it is in the form of division whole power, then again we can single it. If it is power by power, then we need to multiply. If something is power with a 0, it's always 1. If it is in the negative form, it is always by. Moving on to the problems. First question is evaluate 2 power 1 by following laws of exponential. 2 power 1 is 2, which means it is only 1 time 2, right? As it is power 1. Something power 0 is always 1, no matter what the number is. If it has power 0, it's always 1. That is what we have seen. 0 cube is always 0. No matter how many zeros you multiply, it's always 0. Minus 1 power 4 is 1. So what about these minuses? I'll show you. Minus into minus, plus. Again, minus into minus, plus. Plus into plus, plus. If suppose we have 3 ones here as 1 cube, minus 1 into minus 1 into minus 1, then the answer will be minus 1. How? Minus 1 into minus 1, plus 1 into minus 1, plus into minus, again minus 1. But we have 4, so we are getting plus 1. Next, something is in the power of minus, it goes in the bys by the laws of exponential. What we have seen, it's a power minus m, which is equals to 1 by a power m, right? If there is a whole power, then we need to open the powers by the laws of exponential again, which is in the form of a power a by b power m, which is equals to a power m by b power n. That is what we are doing here. 5 square is 25, 4 square is 16. It is in the form of mixed fraction. 1 into 1 by 4. We need to convert it into improper. 4 ones are 4. This should be addition, multiplication, and this should be addition. 4 ones are 4. 4 plus 1, 5 by 4. Whole square. Again open it as 5 square by 4 square, 25 by 16. Next. Express 10, 100, 1000 and so on in exponential form. What is the form of 10? 1 0 as 10, 2 zeros as 10 square, 3 zeros as 3 square, 4 zeros as 4 square, 5 zeros as 10 power 5. Express in simplest exponential form. What are we going to do? We need to express in simple exponential form. So what is the exponential form of 16 and 64? 16 can be written as 2 power 4. 64 can be written as 2 power 6. We need to multiply 16 into 64. That is 2 power 4 into 2 power 6 according to the laws of exponential. If it is in the form of a power n into a power m, then we need to add the powers. A power n plus m. That is what we are doing. 4 plus 6, 2 power n. Similarly, 128 in the form of 2 power 7, 32 in the form of 2 power 5. Now, this is in the form of division. 128 by 32, 2 power 7 by 2 power 5. according to the laws. If it is in the form of multiplication, a power m by a power n, which is equals to a power m by n, right? If it is in the form of product, we are adding. If it is in the form of multiplication, division, we are subtracting. So 7 minus 5 is 2, 2 power 2. Thank you.